Hey, what's going on, guys? Let's do this problem right here. The question is asking 30 gram of C3H8 burns in the air, produces 70 gram of CO2. Calculate the theoretical and percentage yield of CO2. So let's see how we can calculate this one. First thing is we have to put the balanced equation. So this is combustion reaction. So this is going to be C3H8, right? That is burning. So we have oxygen and producing CO2 and H2O, right? CO2 and H2O. So let's balance this one. So the first thing we balance is we balance the carbon atom, and then we balance the hydrogen. So we put 4 hydrogen in front of it. So here we have 8 hydrogen, here we have 8. So that's not a problem. That's not a problem. We have 6 oxygen, 4 oxygen, 10 oxygen. So this is going to be in front of this 5. So now we have the balanced equation, and let's put the information that I have given. So they are giving that 30 gram of C3H8 burns in the air. So 30 gram of C3H, this is the limiting reagent, and this is going to be excess, right? This is going to be excess. So we are always going to be take the limiting reactant, and then we have 3 CO2, and here they are saying produces 70 gram of CO2. So we are trying to calculate the theoretical and percentage yields, right? So this is to calculate the percentage yield, I have to know the theoretical yield, and actual yield. Actual multiplied by 100. So here what they have given is actual yield, because this is what actually produced, and that is actual yield. Theoretical yield means the maximum amount could be produced from this experiment. So that's the theoretical yield. That's what we are going to find. If we can find this one, then we can find the percentage yield too using this equation. So let's try to find the theoretical yield. To find that one, I have used C3H8, this information right here. So they have given 30 gram of C3H8. So we have to know how much it will produce, how much CO2 this C3H8 will produce. So that's what we have to know. To find that one, we have to convert this one into moles first. To convert this one into moles, what I have to do, I have to simply divide this one by its molar mass. So I have to arrange in such a way the gram and C3H8 cancel, right? C3 and grams cancel. So here we are going to have 1 mole C3H8 over the molar mass of this one, that is 44 grams. 44 gram per mole is the molar mass. So that goes in the bottom. So it will cancel. Gram will cancel, right? C3H8. And here we can cancel this gram C3H8 and this gram C3H8. We will be left with mole that is produced. Mole that is juiced, right? So here we have mole juiced, and we have to now know what is the mole that is produced, what is the mole of CO2 that is produced. To find that one, we use the mole ratio. So here we have 3 right here. We put 1 in front of it, because if there's nothing, it will 1. So that is this is what we are trying to find, right? So that's going to be on top. 3 moles of CO2 on top, and in the bottom we have to put C3H8, 1 mole C3H8, so it will cancel and give the mole of CO2. So here I divide this one by 1 mole C3H8. Now these two will cancel, right? Now we have the mole of CO2. Now we have to find the gram of CO2. We have the mole of CO2, but we have to find the gram of CO2. To find the gram of CO2, I have to simply multiply by its molar mass. So that will give me grams of CO2. So I have to put it in such a way it will cancel mole and give the grams of CO2. So first put the molar mass of the CO2, that is 44 gram CO2, and in the bottom this is 44 grams of CO2. In the bottom we are going to have 1 mole per mole CO2. So this mole and this mole cancels, and this CO2 cancels, and we will finally end up with this grams of CO2. So let's calculate the values. And if you notice, we have 44, 44. We can simply cancel this one. And the answer for this one is 30 times 3. And that's going to be 90 grams of CO2. So this is what this 30 gram of CO2 produce. Right? So this is the maximum amount that can be produced using this 30 gram of CO2. So that is our theoretical yield. So we can say theoretical is equal to 90 gram. So this is our theoretical yield. This answers this question right here. Then also they are asking to find the percentage yield. To find the percentage yield, we are going to use this information, use this equation. So here we have this equation right here. Percentage yield is equal to actual over theoretical multiplied by 100. So here what I'm going to do, I'm just simply write percentage is equal to actual, that is the information that is given. This is actually produced. 70 gram is the actual that is produced, and theoretical is the maximum that could be produced. So here the 90 gram, that is going to be the maximum that can be produced, and then we multiply this one by 100, and that gives the percentage yield, right? So if you calculate this one, this will give you 77.8 percentage. So this is the percentage we get, and this is the percentage yield of CO2, and that's how we do these problems. I hope you guys like this video. See you next time.